Welcome to the presentation of our ELEC 327 final project, Longboard Light Painting Speedometer. Our group members are Heng, Thomas Liu, and Bill Wang. Given the highly popularity of skateboards amongst college students, we came up with the idea of creating a speed measuring device for skateboard, which also displays the speed in a creative way, light painting. An LED strip will be taped to the back of the skateboard, leaving a light painting display of speed behind the board. Since light painting requires periodically changing pattern of the LED strip, whose frequency is dependent on the speed of the skateboard, the two parts of this design project come together to form a final product. Let me first explain some of the concepts that we used in this project. First of all, persistence of vision. It's a theory that an afterimage persists 1/16th of a second on the retina. This causes the perception of motion and enables the technique of light painting in photography. For those of you who have taken ELEC 261, you're probably familiar with Hall effect. The production of voltage difference across an electrical conductor transfers to an electrical current in the conductor in a magnetic field perpendicular to the current. Hence, Hall effect sensors varies output voltage in response to a magnetic field. They are often used for proximity switching and speed detection of vehicles. For this project, we used Hall effect sensors, surface mount MSP430 G553, some high-strength rare earth magnets, an LED strip, some AA batteries to power the device, and some capacitors, resistors, and wires. We designed our system as follows. We secured the PCB holding both the MSP430 and batteries to the back of the longboard. The Hall sensor is placed on the truck of the board. A high-strength magnet is placed on the inner side of the wheel. As the wheel turns, the Hall effect sensor will be able to vary its output due to the varying magnetic field caused by the changing of distance between the magnet and the sensor. The LED strip is placed on top of the board for light painting. We designed our code structure such that we first configure the device, after which we enter low power mode. We exit low power mode by entering port interrupt, where we record the number of wheel turns. Then we enter watchdog timer interrupt, which keeps a counter to keep track of the time. When a preset amount of time has passed and the counter in WDT hits its number, we reset the counter, calculate the average speed during this period of time, and then enable the timer interrupt at the same time, disabling other interrupts. Adjust CCR theory according to the speed and display the pattern. In designing the architecture of the code, we applied our knowledge on the power efficiency of embedded systems. We used low power mode to save power and use hardware interrupt instead of polling. Since the frequency of the LED change needs to be controlled, we used timer interrupt. We also used watchdog timer interrupt to record time. In the debugging process, we realized that we have two ways to detect wheel turn from the Hall sensor. We started by using internal ADC of MSP430, which continuously pulls data in a while loop and compares the current reading to a previous one. Since Hall sensor outputs high in absence of a magnetic field and low when magnetic field is strong, if previous reading is high and current is low, the magnet has approached the sensor and a wheel turn is recorded. We also tried using port interrupt. We set it up such that it only triggers on the high to low edge, which signals the magnet approaching the sensor. At each trigger of the interrupt, we record a wheel turn. Since we can enter low power mode when there's no trigger, this method is more power efficient than using ADC. It's also more accurate since it promises to capture every high to low edge, whereas the accuracy of ADC is highly dependent on the sampling rate. We chose port interrupt eventually, but luckily, since the sensitivity of Hall sensor we used isn't very high, but we did use a high-strength magnet, the sensor reading has little noise and the output jumps from high to low instantaneously without any in-between values. As for light painting using the LED strip, the LED displays speed as pixelated numbers of 12x8 arrays, which means that each number is displayed as 8 columns, requiring a LED strip to be programmed 8 times to display each number. Now let's look at some of our results.
1, 2, 3, go.